So the opener for today is what we call a proportion. And we want to solve this proportion. 6 over 8 equals 4n minus 1 over 28. Well, you might remember from algebra that in order to solve a proportion, you can do what's called cross multiplying. Now, the idea behind that is the same as what we did for solving equations. For example, if I multiply both sides by 8, the 8's cancel there. And then if I multiply both sides by 28, then the 28's cancel there. So in effect, I multiplied the 28 times the 6 and the 4n minus 1 times 8, which is what we get when we cross multiply. So it's nothing new, no magic. We're just following how we solved equations. So 6 times 28 equals 8 times, be careful, the quantity 4n minus 1. So we're going to have to distribute this 8. All right, so 6 times 28, and that's 120 plus 48 is 168. 8 times 4n is 32n. 8 times negative 1 is negative 8. So we're going to add 8 to both sides. And we get 176 equals 32n. And then we divide by 32. And we get n equals, and either we can get a calculator or maybe it won't work out to be a nice number. So we're going to have to, let's see, 5 is 160. So it's not going to be a nice number. So you can either try and reduce the fraction, find out what numbers go into both of those. 16 I know goes into both of those. 16 goes into that twice. 16 goes into that 11 times. So we wind up getting 5.5 for n. Or you simply could grab a calculator and divide that and you'll get 5.5. All right, so that's how we solve a proportion. That's going to be useful when we get into our next unit, which deals with similar figures. So reductions and enlargements. We learned in the last unit that triangles can be congruent if all the corresponding angles are congruent and all the corresponding sides are congruent. But if you remember, there was no angle, angle, angle congruence postulate or theorem. And that's because, what if we took a picture and we just enlarged it on a copier? Those two pictures are still similar, but they're not congruent. One's bigger than the other. Or likewise, we could have made it much smaller. So these are what we call similar figures, but not necessarily congruent figures. So in general, we'll talk about similar polygons. Figures that are similar have the same shape, but not necessarily, and I want to highlight, not necessarily, but they could be the same size. So all the triangles we did in the last unit when they were congruent, they were similar, but even a more strong statement would be to say that they're congruent. Polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. And we just got done solving a proportion. So that idea we're going to use to prove whether figures are similar or not. So some examples will probably make this a lot more clear. All right, so here we have two figures. And let me draw an arrow here so we can refer to certain parts of them. So if you notice, angle C is congruent to angle G. Angle D is congruent to angle H. Angle A with angle E, and angle B with angle F. So since all the corresponding angles are congruent, we have a matching with all those angles, we would say that these two figures are similar. Now, how do we write a similarity statement? Start with the first picture, and we'll use the one, usually we go left to right, but it actually doesn't matter. But I'll start with the first figure, and what if I decided to go alphabetically? A, B, C, and D. That's going to be similar. Now remember, when things were congruent, we use that symbol. But similar means they're not necessarily equal, so we're going to leave off the equal sign. And so now, it didn't matter how we wrote the first group. I could have started with A and I went clockwise. I could have started with C and gone counterclockwise. That doesn't matter. But once you establish the order here, now we have to make sure we match up with the other figure. So when I start with A, that's going to match up with E. And then B matches up with F. C matches up with G. And D matches up with H. So that's one possible answer for a similarity statement. Somebody else might have come along and said, oh, I wanted to do the smaller figure first and start with G, and said G, F, E, H. And that would be fine. But you just have to make sure then in the other figure you do it in the same order. So G matched up with C, F matched up with B, E matched up with A, and H matched up with D. So that would be another correct answer. So there's a lot of correct answers. But that's what a similarity statement is. You're saying one of the polygons is similar to the other. And the order you write the letters tells you how things match up. So another thing that you should be able to do is list the congruent angles. So from a similarity statement or from a picture, we can write all the angles that match. So for example, angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. So I'm listing the congruent angles. The next part says statement of proportionality. Now remember, the opener was a proportion. So we're going to write fractions that are equal. So what I need to do is match up the sides. And the easiest way to do it is, if I'm looking at my similarity statement, I'll just say AB matches up with EF. And then BC matches up with FG. And CD with GH. So I'm just matching up the sides. So the length of side AB over the side EF, so AB over EF, that ratio should be the same as the ratio of any other two matching sides. So for example, BC with FG. And then side CD matches up with GH. And finally, DA matches up with HE. So what this is saying is that if you take the ratio of any two corresponding sides, that'll equal the ratio of any two other matching sides. And so all these ratios should be the same. And that's important because then if we know some of the sides but we're missing some of the others, we can write a proportion. Any two of these fractions we can set equal, and we'll be able to solve for a missing side. All right, so a couple of things just to reiterate. A similarity statement. Grab my arrow back here. So the terminology, at first it's new, but you'll get used to it. Similarity statement means you're writing something like this. Listing the congruent angles, we've done that before. That should be straightforward. And statement of proportionality, that's when you're writing a proportion. So you're writing a bunch of ratios and setting them equal to each other. And we should be able to come up with the statement of proportionality with either the similarity statement or with the picture. Either way. All right. Let's look at some examples. Are these two polygons similar? If they are, let's write a similarity statement, and let's write what we call the similarity ratio. All right, so let's first of all, an arrow, let's check. All the angles, corresponding angles have to be equal. So this angle W equals angle P, angle X is congruent to Q, angle Y is a right angle, that's equal to angle R, and angle Z is congruent to angle S. So yes, all the corresponding angles are congruent. So the figures are similar. So that's a check. So now we need to write a similarity statement, like we did in the last one. So I'll start with the one on the left, the bigger picture, and let's say I start with, let's start with y. Doesn't matter. And let's go counterclockwise. So y, x, w, z is similar to, now go to the other picture, what matches up with y, that's r. What matches up with x, that's q. And then with w is p, and z matches with s. So there's your similarity statement. Now, I'm being really careful here because a lot of times the two pictures are drawn with the same orientation. But what we could do is we could take one of these and spin it around or flip it over, and then we have to be careful how we're matching up stuff. So don't just always think it goes exactly the same order as the picture. The picture might be flipped or twisted around. Okay, so now we have to write a similarity ratio. Well, notice we decided that all the angles matched, so these were similar. But we actually didn't check the ratio of all the sides. And we need to do that if we have lengths of sides that are given. So let me figure out which sides match up. Now the 6 is going to match up with 4 because that's xy and qr. If I wasn't sure, if I didn't know the angles, I would say, well, 6 is the smallest side here, so that's got to match up with the smallest side in the other picture. So that's how I know 6 and 4 have to match up. So let's start writing some ratios. So 6 over 4, is that equal to, now let's pick another side. Let's go, how about 9 would match up with that 6. And then another side, how about the 12 with the 8, and then the 15 with the 10. All of these ratios have to be equal. How do I know if they're equal? Well, we know how to tell if fractions are equal. We could reduce them all and see if we have the same fraction. Or we could grab a calculator and divide them. That would be another way to do it. Sometimes that's easier depending on the fractions that we have. So if I do 6 divided by 4, I get 1.5. 9 divided by 6, 1.5. 12 divided by 8, 1.5. And 15 divided by 10 obviously is 1.5. So because all these ratios are equal, then I know the polygons are definitely similar. So I actually do have to check that. Not just checking the angles is enough, as you'll see in a later example. Okay, so now let's get to the question, what's the similarity ratio? Any one of these fractions reduced. So if I reduce 6 over 4, I get 3 over 2. That's the similarity ratio. That's the ratio of this figure to this figure. It's on a scale of 3 to 2. If you reduce 9 over 6, you still get 3 over 2. Reduce 12 over 8, divide 4 out of both of those, you get 3 over 2. 15 over 10, divide both by 5, you get 3 over 2. So that's your ratio. All right, let's look at another example. Are these polygons similar? Well, once again, notice all the corresponding angles are going to match because these are two rectangles and all the angles are 90. So all the angles match, so we're thinking maybe they're similar. But let's check the sides. We have 15, we know the one across is also 15, and we have 8. Here we have a 10 and a 3. Which one should we match up? Do we match up the 15 with the 3 and the 8 with the 10? Or do we do the 8 with the 3 and the 15 with the 10? Well, since the 8 is the smaller side here, and 15 is the bigger side, let's match the 8 up with the smaller side in the other picture. So let's check, is 8 over 3 equal to 15 over 10? Once again, you can grab a calculator and divide these. When you divide 15 over 10, we get 1.5. We did that one already in the last example. When you do 8 divided by 3, you wind up getting 2.6 repeating. Those are not the same ratios, so no, these polygons are not similar. So it's important that all the angles have to match, the corresponding angles have to be congruent, but the ratios of the corresponding sides also have to be equal. Let's look at some more examples. Are these polygons similar? Well, you might just want to jump to the sides and start doing those proportions, but before I do that, let's figure out the missing angle. All the angles add up to 180, so if I have 130, subtract that from 180, this angle would be 50. In my other triangle, 30 plus 40 is 70, 180 minus 70 is 110. The angles don't even match up here, so I don't even have to check the sides. The answer is no. So the first thing is check the angles. If the angles match, then you can go ahead and do the ratio of the sides. But don't waste your time doing the ratio of the sides if the angles don't match. All right, so now we have an example of a similar figure here, two similar figures, and we can solve for a missing side, now that we understand what similar polygons means. So notice, this smaller picture was enlarged to make this bigger picture. So we have the Liberty Bell here, which is 3.5 by 5 units. We want to enlarge it, and our poster is going to be 16 by something. We don't know how tall it should be. So the 3.5 matches up with the 16, and the 5 matches up with the x. Let's write a proportion like the opener and figure out what x should be. So we have 3.5 matches up with 16, and that'll equal 5, which matches up with x. Now that's not the only way we could have written this. Somebody else might say, hey, I want to do the 3.5 over 5, the two sides of the smaller rectangle, and that should equal the two sides of the bigger rectangle. Maybe that would be the way to do it. But notice in either case, when you cross multiply, here you're doing 3.5 times x equals 16 times 5. Here, 3.5 times x equals 16 times 5. It's the same calculation when we cross multiply. So there's more than one correct way to set up your proportion. So we cross multiply, we get 3.5 times x equals 5 times 16, which is 80. And then we do 80 divided by 3.5. And if you need to grab a calculator, grab a calculator. And we get 22.857. So we don't get a nice number. And so if we're going to round this, we would say, if we're actually measuring a poster, we would want, let's say, 22.9 units for x. And there's your answer. If you wanted the exact answer, I guess we could leave it as 80 divided by 3.5. But we usually don't have decimals within fractions. So if I multiply top and bottom by 10, I get 800 over 35. And then I could reduce that. 160. 5 goes into 800, 160 times 5 goes into there, 7. So that would be the exact answer, 160 over 7. All right. Couple more quick ones. Polygon JKLM is similar to polygon PQRS. So they're telling us the order. The J matches up with P. So when we look at our figure, J matches up with P, K matches up with Q, there's Q and K. So that tells me that this 10, the side length 10, matches up with Z. And then K to L and Q to R match up, so 15 matches up with 6. So let's solve for Z. Let's write a proportion. So how about 10 matches up with Z equals 15 with 6. So that's one way to do it. Somebody else might come along and say, I want to start with Z. Z over 10 equals 6 over 15. Somebody else might say, hey, I want to do 6 over z equals 15 over 10. And yet, one person who wasn't paying attention might want to do 10 over 6 equals 15 over z. Which ones are correct? Well, we know the first one is because we set it up according to the similarity statement. When I cross multiply, I get 10 times 6 and 15 times z. Over here, it's still 10 times 6 and 15 times z. This one, 10 times 6, 15 times z. This one, no, 10 times z, no, that one doesn't work. So you can see there's more than one way to do it, but you have to be careful to make sure things are matching up correctly, according to your similarity statement. All right, so let's cross multiply. We got 6 times 10. And by the way, let me show you another way of doing these. Instead of actually multiplying out 6 times 10, I realized that I can divide both sides by 5. And now I've got 6 times 2 equals 3z, but 3 goes into 3 once and 3 goes into 6 twice. So I have 4 is equal to z. If that didn't make sense to you, that's okay. Just do 60 equals 15z, divide by 15, you get z is 4. All right, let's do one last example. Solve for the variables if the two polygons are similar. So they're telling us they're similar. We have two trapezoids here. So I know the smaller base has to match with that smaller base. This larger base has to match with that one. And we know the angles are actually congruent. So those two angles are congruent. So I know that z is equal to 60 degrees. Let's start with that. The sides are proportional. So let me say 15 over 12 equals 21 over y plus 5. Notice the color coding on how I did that? All right. So now we're going to cross multiply. It's just like the opener. So 15 times y plus 5, careful, use parentheses so you distribute, equals 12 times 21. Now I can distribute, multiply all this out, or I can save myself some time and divide out common factors. I don't want to confuse people, so if you understand that, I would do the shortcut. Otherwise, let's distribute. 15y plus 15 times 5 is 75, equals 12 times 21. What's that? 210 and 42 is 252, I believe. We'll check in a calculator in a minute. Then I'll subtract 75 from both sides. Minus 75 is 177, I believe. And so this isn't going to go in evenly. Y is equal to 177 over 15. All right, so let's check on a calculator. First of all, let's make sure that I did 12 times 21 correctly. 252, subtracted 75, and then divided by 15. So 11.8 is our value for y. A lot of times early on, the answers wind up being nice integer values. But later on, or with real life examples, you're not going to get such nice answers. So be prepared to get decimals sometimes. So y is equal to 11.8, and we found z already was equal to 60.